Hey guys, I thought I'd give you a demonstration of the one-way ANOVA assignment. So, like usual, I am here on the GitHub repository for this assignment. You will want to hit the fork button and fork a copy of this to your own account. And then once you do, you'll want to download the zip file for this if you're using that method. And once that downloads, you can open up the zip file and you want to extract all and have the show extracted files when complete option checked and extract that. We'll go ahead and close the zip copy. And once you get that open, you want to open up the instruction sheet or the answer sheet. Okay, and it looks like I forgot to change the text on the top of this. All right, so as usual, you don't need to turn these answer sheets in. These are just here for your convenience to keep some notes so you can answer the assignment questions in Canvas. And I do have three main sections to these. One about the study information with that heading, one section about the data set information, and one section about the test information. And I do this and have you guys read through this each time so that you remember that whenever you're analyzing data, you really should go back and look and see how are these data collected and what's the general purpose of them. So we won't have much to fill out for this assignment for the study information, but I leave it there to remind you that these are things you really should answer about a data set before analyzing it, because how you interpret the results of your analysis really depends a lot about the context in which it is done and the circumstances surrounding how the data were collected and what they're being used for. So there won't be much there for you to answer, but looking at the research questions for this study, Field does describe this data set and it's fabricated, but he does kind of describe the variables and the general purpose of the data set in his chapter 12.2. So I would encourage you to go read through that section of the book to kind of understand the background on these variables and what he's has in mind when he's looking at this. So down in the data set information, we're going to look at the at this data set. So we're going to open up this puppies.dave data set in Jamovi. So I'm going to open Jamovi on my computer. And we'll go to File and Open and Browse, and we'll get into the One-way ANOVA file and open the puppies.save dataset. okay. And I think his description basically has people rating happiness and with a control group, 15 minutes with a puppy and 30 minutes with a puppy, and comparing these groups. So let's just double check that he has these set up correctly. I do have a note in here. So this person is an ID variable. So in Jamovi, I would go ahead and switch that to ID. If I was in some other software, which they don't always have an ID variable, I would make it nominal. These are numbers, but really they're just unique identifiers. So this could be any kind of alphanumeric representation that's unique. So it's not a variable that we would use in an analysis. So we are going to mark that as an ID variable. Dose is nominal with 3 groups, control 15 minutes and 30 minutes. That looks correct. And happiness, this comes out as continuous, and I do make quite a note in this answer sheet. I, for all intents and purposes, normally would count this as an ordinal variable, in which case ANOVA is really not a great test to use because normally the outcome variable in ANOVA is continuous. So I do add that one caveat to this data set that I would normally probably end up using something non-parametric with an ordinal outcome variable. But we're going to go ahead and go with his example. Just be aware that normally if this were on a test, I would call this an ordinal level of variable and not continuous. So, but we'll leave it continuous for the purpose of this demonstration. I don't see any missing values, but again, that's something that's really going to be best looked at using descriptive statistics. So we can go ahead and take a peek at that, go to Explore Descriptives, and we have our continuous variable under variables, and we're going to go ahead and split the data set by dose, and we can see that we have 5 in each group, no missing data. We have means and standard deviations there. We can double check. I do usually like to get skewness and kurtosis and take a peek at those, and a normality test. Again, skewness is probably the more important thing that we're looking at, and we take skewness divided by the standard error of the skewness, and if we don't have a value of 2 or greater, then we really don't have much of a problem with it, and we're okay there. So we're okay with our normality assumption here, and you'll see that our Shapiro-Wilk test for our normality test is not significant for any of those groups, so that really does look okay. We'll go ahead and get a plot. This is continuous data that we're looking at, so we'll go ahead and get a histogram and a box plot, and you'll see that Jamovi gives us this nice stacked histogram with our 3 groups there, and it's a pretty handy way to look at those data, and there are the box plot for it. We don't see any outliers there, so we're really probably okay with our normality assumption there. So we didn't really see any issues with our data. We don't really have any extra manipulations to do here. No missing data, no outliers. Again, we would look at any descriptives, demographics if we needed it for a study, but we're not doing anything with that here because this is just a demonstration or an assignment sample data set. And then we're going to look at One-way ANOVA. If you don't already have these things assigned, if you don't have them installed, you can install these Jamovi modules, and again that's done in the modules section and Jamovi library, and you can go pick them out and install them. I think I already have them on this machine, so I won't go through that. We are going to, in StatCat, just look at choosing the correct statistical test. So we're going to go to Jamovi Analysis StatCat and look at relationships prediction and group comparison, because this is doing group comparison. So we'll go to Jamovi Analyses StatCat and relationships prediction and group comparisons. And our dependent variable is our outcome variable, and we're going to put happiness in our outcome variable, and dose is our grouping variable, and we'll put that into our independent variables box. And you'll see that it notices that we have 3 groups that we're comparing, and it suggests a one-way ANOVA. And I do believe these look like links, and you can actually go follow that, and it might give some additional instructions. So if we had problems with our normality test, then the non-parametric equivalent of a one-way ANOVA is the Kruskal-Wallis test. So it also suggests that alternative there. So a handy tool for helping to decide on the right test. If you put in some sample data with the correct levels of measurement, this may help you give a little guidance on picking the right test, because that's one of the challenges of designing a study, is knowing how you're going to analyze your data. Okay, so we would look at our assumptions, and in Field, he lists most of his assumptions for things based on the linear model, like ANOVA in Chapter 6. And you can look at, you do want to look at the field text, Chapter 12, Section 3, to also look at those assumptions. So our outcome variable is continuous. We meet that assumption. We have the assumption of additivity and linearity, which we should be just fine on. Normally distributed sampling distribution. For large samples, usually you're okay, because because of the central limit theorem, you're okay with this. But with small samples, you do care more about the normality, and we did check that, and our data seem normally distributed. And homoscedasticity, which means we have equal variances. We haven't tested that yet. We're going to look at a test called Levene's test to look at homogeneity variance, which is the homoscedasticity assumption, but when you have grouping variables, then we'll look at the variance in each of the groups to see if they're equal with Levene's test. Independence of observations, usually you knows that by the study design. We shouldn't have any individuals that are related to each other in some way, or be looking at the same individuals at different time points. So we know that we meet that because these are people in assigned to different intervention groups. And I didn't remove that assumption, so I will just take that out. And you can do an ANOVA with just 2 groups, but usually it's 2 or more, so I'll just go ahead and leave that in there. And no extreme outliers. So now we can look at our null hypothesis significance testing steps, and our null and alternative hypothesis. The null is always some variation on there is no difference, and in this case we're looking at groups with a continuous outcome variable. So our null would be there is no difference between any of the means of these groups, and our alternative would be there is a difference between at least 2 of the means of these groups. Our criteria for rejection, I do give a little explanation of when you might use something other than alpha 0.05. We're going to go ahead and stick with alpha 0.05 for this test. So that will be our criteria for rejection. And we're going to calculate the test statistic. Now there are a couple ways that you can look at that. And I do give you a little bit of explanation here in Jamovi. So we're going to just take a peek at these two ways. So we're going to go to Analysis ANOVA and One-way ANOVA. Analyses ANOVA and One-way ANOVA. And you could, let's just go ahead and we'll put these in here and take a peek at them. But I usually use the other way that I'm going to show you instead of this. So we're going to put happiness as our dependent variable and dose as our grouping variable. And I would usually get descriptives and plots and our homogeneity test and normality test and a post hoc test. We would pick something like Tukey. And we can see that our normality test here with, or what I'm looking for is our Levene's test, our homogeneity variance Levene's test, and you can see it's not significant. So you can see that we have picked Welch's, which does not assume equal variances. We could go ahead and add in our Fisher's, and you'll see we have two different values here. We would use this line for Fisher's because we checked our homogeneity variance with Levene's test and it was not significant, so we could go ahead and use that. But there's not much of a problem. You'll see that it does adjust these values for degrees of freedom, and the F will be a little different, so the P values will be somewhat different from each other. So we would go ahead and we could use Fisher's because we passed our homogeneity variance test. But I would usually recommend using our other menu, which you're going to look at, and that is Analysis, ANOVA, and ANOVA. And this does not necessarily assume that you're just doing one-way ANOVA, but we're going to go ahead and put happiness as our dependent variable and dose as our fixed factor. I believe I have told you before that a factor is a variable that divides people into groups. So it's just another name for a categorical variable in statistics. So that's our factor. But this menu gives us these effect sizes. And when I was in school, I used SPSS, and that would give us partial eta squared, and so that's what I was used to looking at. However, I believe Field recommends using this omega squared, so you could go ahead and get that. And let's see what other things I told you to get with this. Okay, so we've got happiness, dose, omega. We're going to check everything under assumptions, and we're going to check Tukey's and Cohen's D under post hoc tests. So we're going to go to assumption checks and get our homogeneity test, normality, and a QQ plot. And under post hocs, we're going to go ahead and keep Tukey, and we can move dose over and get the Cohen's D for those pairwise tests. And I don't have you do anything with this, but I do notice that this save menu is actually new this year, and it looks like you could get the residuals saved for some additional testing. We won't worry about that for this class, but I do see that this is something that's been added since the last time that I have done ANOVA in Jamovi, so that is useful. Okay, so we're going to go through and look up some values off of these tables. So we're going to look for F, our degrees of freedom, for dose and for residuals, our p-value, our effect size, and which groups had significant difference on the post-hoc tests and which group had the highest happiness. So we can see that we have our sum of squares for dose and residuals, and there's our degrees of freedom, 2 and 12, and we have a value of F equals 5.12, and I believe that matches the value that we saw earlier under Fisher's, so that is handy. And I do believe that Welch's is the option that you only had under the One-way ANOVA menu that we didn't have here. So if you're worried about violating that assumption, that homogeneity variance assumption, you could go and get the Welch's test off of that other menu. So we do have our Levine's test, homogeneity variance, and we do see it's not significant, so we pass our homogeneity variance assumption, and we know that there's no significant difference in the variances of our three groups here. We also passed our Shapiro-Wilk test. Whoops, I'm down here on the wrong thing. So, but there's our Shapiro-Wilk test. We do have a QQ plot which shows these pretty close to this line, so that's a good sign that our normality assumption is met. Now, if we have, so on this, here's our F and our P value, 0.025, that is significant. And look at the field text about how to interpret omega squared. I'm kind of assuming, okay, I did just do a quick Google search, and on the omega squared, looks like they're citing field less than 0.01, very small, 0.01 to 0.06 is small, 0.16 to 0.14 is medium, and greater than 0.14 is large. So if we go look at our Jamovi effect size, 0.354, that's a large effect size according to field. So that's, I guess I just recommend get used to looking up effect sizes. There's a number of different effect sizes for different statistical tests, and sometimes you need to go do a little Googling to see how to interpret those effect sizes. I would remind you that effect sizes are kind of our clinical significance, and p-values are statistical significance. So even though this is only p.025, this effect size was large, and part of why we're seeing that is because we have a pretty small sample size here. If we had a larger sample size, that p would be more significant, I guess you could say. And just remember that p-values are totally dependent on sample size. So that's one thing that's useful about effect sizes, is it's kind of a estimate of how big this effect is without necessarily being so affected by the sample size. So this does say it's a large effect. So the fact that this is significant tells us there's a difference between these groups somewhere, but it doesn't tell us where the difference lies. And that is part of why we get post hoc tests for ANOVA. And Field talks a little about some different post hoc tests, and from what I, when I was in school, Tukey is kind of a middle of the road. It doesn't make a huge correction because we are doing multiple tests here. Bonferroni is the most conservative, and it basically takes the p-value and divides by the number of tests you're conducting. In this case, we're doing 3. So if we you were using a p-value of 0.05 and we're doing 3 tests, then instead of using 0.05 as the level of significance, we would use 0.16, something like that, 0.05 divided by 3, 0.016. And you see you can choose some different things here. Chaffee is kind of middle between Tukey and Bonferroni. I've never really used Home. I think Field talks about it a little bit in his text. So, and SPSS has a lot of different options, but I really only used, you know, Tukey and Bonferroni if I was trying to be extra conservative. So there's a lot of different post hoc tests used for some different conditions. You can Google those and read about them, but you know, Tukey, Chaffee, Bonferroni, and no correction are some of the most common. So if we look at this, what we're going to do is we're going to have our control group and being tested against the 15-minute group and against the 30-minute group. And if we go over and look, we see the p-value between control and 15-minute group is 0.516, which is not significant. The p-value between control group and the 30-minute group is 0.021. That is significant. And then we only have one more combination, and that's a test between the 15-minute and the 30-minute group. And we see that the p-value for that is not significant. So the difference and the reason why this is significant is because there's a significant difference between the control group and the 30-minute group, which is what we would say. The plots from the One-way ANOVA actually makes this a little bit easier to see, and this ANOVA menu doesn't really give us a plot, and I do like to see a plot. So, you know, maybe it is best to do both, because these plots really show you, you know, who's low and who's high. Yeah. Oh, and we can get a plot. So let's go ahead and get a plot right there under our other test. So under the estimated marginal means, we can get a plot. And there you can see there's our plot. So that's useful. So under the estimated marginal means table or menu, move dose over to marginal means, and then you can click the observed scores plot, and you can see a similar plot for that. So little more complicated to get that. Okay, let's look on our instruction sheet, see what else it's asking you for. So which group has significant difference? We knew that was between our control group and our 30-minute group. And the which group has the highest happiness, and we can see that is our 30-minute group right there. We did talk about Levine's test. You can try a robust ANOVA. So if you have any worries about meeting assumptions, you can do that. So we're going to go to Walrus Robust ANOVA. Walrus Robust ANOVA. And we can move happiness into the dependent variable, dose in the factor. Method, we'll leave the default. Go ahead and get a post hoc test. And did I ask you for anything else? No. So that's probably good enough. You can get bootstrapped estimators there if you want to. This will probably take, oh, it's a one-way design, so we won't do that. Okay. I do give you some of Field's description of alternatives when you do have problems with assumptions. When you don't have any problems with assumptions, then you can run analysis ANOVA. And if we had problems with normality, then we could run the non-parametric Kruskal-Wallis test, or you could do a robust ANOVA. Problems with homogeneity variance, you could run Welch's or the robust ANOVA. Field 12, chapter 12, section 11 gives you an example of how to report the results of this. You don't need to write that out here. And we're going to save this Jamovi file and export our output. So we'll go to File, Save As, Browse, make sure that we're in our correct folder, which we are, and we can just leave that name alone and save that. And to export our output, we right click somewhere in the output and go to All, Export. I would go to Browse, make sure that we're in the correct folder, and we are, and we can call this something like Puppies Output. Okay, that should be good for that. And then we're going to open up our R markdown file, our .rmd file, and run that in RStudio. So there's our .rmd file, and we can right click on that and go open with and pick RStudio. And you can read through this. Like usual, we're going to load our correct packages, make sure that our text blocks run. We're going to install any if they're needed. We should have these all installed, so it really should run quickly. If you don't have them installed and this takes several minutes to run, you just have to be patient and let it run its course. We're going to run the library command on each package to make sure it's loaded into memory so we can use it. I do talk in here about how ANOVA is a linear model, and so we're going to open up our file here. Looks like I'm using the file choose command. You could just change the name of that to our puppies.save, and do recall that sometimes this file choose command, the pop-up can open up behind this window, and sometimes you have to search for it. I'm just going to go ahead and change this to the puppies.save dataset name, so I don't have to mess around with the if that gave you an error like that, we can double check that our session set working directory, we can choose the directory and make sure the directory should be okay. Okay, I think I found an error. I should have had this in quotes, and so I put the name of the data set in quotes, and you'll see that that now ran. And my data set, you can see that it looks like it did in Jamovi. There's our ID variable, our dose, and our happiness. So we're good on that. I'm going to go to our one-way ANOVA assignment. You can get the R code from the Jamovi output. You don't need to do that here, but I do give you some instructions on how to do that. And we're going to go ahead and look at this as a linear model. and how you'd run this ANOVA as a linear model, like a regression. And we would get, there's a plot for happiness we can look at, and you'll see there's our three histograms run, and we're going to switch our dose to a factor, and that will allow us to run a box plot in there. As you can see, this gives us very similar output to doing it in Jamovi, but it is a little more complicated. You do have to do a little bit more manipulation to get things to run in R. And then this talks a little bit about categorical variables in regression. And when we have more than two categories, we have to create something that's called dummy codes. And this gives you some code and some explanation. So if you want to understand a little bit better, I'd encourage you to read through this. And we're going to create some dummy codes there, dummy variables, and then we can run our linear model and get the summary of the model. And there's what it would look like with our two dummy codes, one for 15 minutes and one for that, and how they would look at that. You might want to, if you want to understand the relationship between ANOVA and regression, this is worth spending some time to try and understand the output, but I'm not going to explain a lot of it here. And we can get some standardized residuals like we have before. And finally, there is our ANOVA command from Jamovi, just to compare what Jamovi gives us as output. And you can see our output that we had before and some of those things. So there's an example of that. To get this, you'll go knit and knit to markdown document. We'll give that a minute to run. Takes a couple minutes sometimes. You can see that it's putting some files in, and there's my pop-up with that, and that will be in my folder, so that should be okay. I don't need to save this workspace. I don't care about keeping that. And there's my One-way ANOVA markdown document. You would go back to your repository and go to add file and upload files, and you could drag your, make a little space. There's our markdown file, there's our PDF, and there's our Jamovi file OMV, and drag those to your repository, and you will upload them, and then you'll click on commit changes. I'm not going to do that because I'm not going to save these here. And then you can turn in the URL for your repository into Canvas for your assignment. I hope that helps show you how to complete this assignment in Jamovi and RStudio, and I'll talk to you guys later.